Hello everyone. Today we will be talking about regularization. So let us get started. So basically regularization is a machine learning technique which we use to prevent overfitting. So we have already studied what exactly is overfitting. So when overfitting is increased, obviously the variance will increase. And mostly what happens is when we don't want our model to overfit, because the model becomes very complex, it starts learning from unnecessary things, which is not a very ideal situation. So for that reason we use a technique called as regularization, so that we could prevent overfitting. So there are a lot of benefits why do we go for regularization, but one of the most important thing is that to avoid overfitting, we perform a technique, or there is a machine learning technique which is used for preventing the overfitting, and that is basically we call it as regularization. So let us understand why do we need regularization. So as I said, it prevents overfitting. So basically what happens, the what are the conditions where we can say overfitting occurs? So the first condition is that the model it starts memorizing the entire training set. It may also happen that, yeah, obviously if it memorizes the training set, then what will happen, everything from the training set it will give 100% accuracy if we try to test on the same thing. But when unseen data is given to the model won't be able to perform. So that is overfitting. Then that means variance will occur there. It will start picking up unnecessary patterns, it will start learning from each and everything. And if model starts learning for everything, that is not a very ideal situation. So we are also considering whatever is needed. This is something that we don't want from our model. Then it also improves the generalization. So basically everything, the aim is to enhance the performance of the model. So that is happening here. So that is why again we need regularization. Then the complexity. So basically what is complexity? When when do we say that model is very complex? That means exactly the same thing when variance occurs. So basically the aim, we want to make our model stable, neither too simple nor too complex. Everything should be balanced. So that is why we perform regularization. So basically, just to define or just to summarize this slide, we would say that regularization is a machine learning technique which is used to reduce the overfitting. So basically, when are very higher chances that regularization occurs? So the first important thing is when we have a data set that is very huge, or there are a lot of features in that particular data set which are not even required. So there are a lot of cases where this may happen, that important features are just four, but along with it there are multiple features that are unnecessarily there. So if we don't use regularization techniques there, what will happen is our model will start learning from each and every feature. So let us say only four features are important, but we are considering all 10 features. So which this is not an ideal situation. So what exactly regularization does is it adds a penalty or to the features. It tries to remove those features. Regularization try to remove those features or try to reduce their like values, so that that won't affect our results. So that is basically regularization. Now we will discuss regularization in detail and understand how exactly regularization works and what are different types of regularization. So there are two types of regularization, basically L1 regularization and L2 regularization. So L1 regularization use a concept of Lasso regression, and the second one uses the concept of ridge regression. So now we are going to study both of them in detail. So first one is lasso regression. The aim of both of these regressions is to reduce the overfitting. So basically what is L1 regression? So we are going to study what is L1, what is L2 regression, and what is the difference in between both of them. So a regularization is a technique that adds a sum. So basically we have linear regression. So these are, we would say, L1 regularization is linear regression plus it also uses the concept of Lasso, and L2 uses, so basically they are variants of linear regression, extensions or different variants of linear regression. So obviously they will have a equation, they will have some penalties, they will have a let us say equation, the value, the weights, and then the values assigned to it, that will be there. So what it tries to do, Lasso regression, it is they try to give a loss function. They adds loss function to the coefficients of the model. So when we have that equation, it tries to add some value in the loss function so that it will be reduced. And the L1 regularization, the most important thing is the irrelevant features or which do not affect the performance of the model. So our model or Lasso regression specifically makes those features exactly zero. So this becomes exactly zero, that means it removes the unnecessary features completely. So let us consider we have a data set having some table name, then we would say number of hours a student studies, and then the student is pass or fail. So let us say that this is the data set that we are having. So now number of hours studied and pass or fail. These two are only important feature. How will my name decide? Name don't have any relevance when it comes to the number of hours study. It don't mean that if my name is so and so, then the student will be pass, and if my name is not this, I will be fail. So name here is completely irrelevant feature. So when we are trying to use Lasso regression, so there will be a equation, some weights of everything, let us say w1 x1 plus uh, weight of second one y1. So let us say we have this equation. So what exactly Lasso regression does, it tries to add some penalty to it such that making it completely zero. So that what will happen, if something is multiplied by 0, obviously the answer will be 0. So what will happen, this feature or the importance of this feature will be automatically gone. So we can say that Lasso regression has a built-in capability or built-in feature selection available along with it. It is a very important difference in between ridge and Lasso regression. When we have L1 regression, the feature selection is inbuiltly done. We do not, there are multiple different ways in which we perform feature selection. We will be having a complete detailed video on feature selection, but there are few models which can perform feature selection inbuilt, like decision tree. There also we only consider the features that are giving us the maximum output or whatever is required. We use Gini index and information gain. These two concepts are used there to find out which feature will give us the best results, and we will pick up only those features. So this is again feature selection. So there are few models which built-in perform, they have this capability to perform feature selection, and Lasso regression is one of them. Both of, remember that L1 regularization and L2 regularization, both of them try to reduce the overfitting. But specifically Lasso regression, what it does is it forces the coefficient of the unimportant feature to become exactly zero, so that feature is completely removed from the data set and we don't consider it for training. So this is feature selection. So Lasso regression has built-in feature selection. And then ridge regularization. Ridge regularization is basically they work in two different ways. So it tries to square up the values, and add this the sum to it, but again the aim is again to reduce the overfitting. So it also tries to reduce the large coefficient or the unnecessary features. What are the unnecessary features? If their coefficient is very high, again ridge regression tries to reduce them. But the very important thing here as well is that even if we try to reduce it, we cannot make it exactly zero. So we can say that lasso regression has built-in feature selection present in it, as it makes the less important coefficient or the features having less importance, their coefficient is automatically made zero in lasso regression. Whereas in ridge regression we do not see anything like this, that is reduced, the coefficient is reduced but it is never made zero. So this is what lasso regression is and the ridge regression is. So now a very important thing, L1 regularization and L2 regularization are concepts where we have built-in feature selection in L1 regression and we do not have any such thing in L2 regression. But both of them, if we say that lasso regression, so lasso regression is combination of linear regression. So in both the cases linear regression will be there. So basically we can say lasso regression is linear regression along with feature selection and ridge regression. So basically when we want to perform regularization or when we don't want our data set or our model to be having overfitting or the variance, in those cases we can go for ridge and lasso regression. So both of them have linear regression, but the only difference is lasso regression comes with feature selection. That means unimportant features become exactly zero, their coefficient becomes zero, whereas in ridge regression there is nothing like this. So this is the difference in between ridge and lasso regression. So now we have difference in a lot of exams, or whenever somebody talks about lasso regression, the second question will be automatically for ridge regression. So ridge and lasso is like they are one unit, we can say. Whenever one talks about ridge or lasso, one of them, the other one automatically follows. So this Lasso uses L1 regularization where we perform feature selection. So this is the basic and very important difference in between both of them. Then this one uses L2 regularization. Then we have, it basically adds absolute value of the coefficient as a penalty. So it tries to add it so that it can balance out and somehow it can make it zero. Whereas what it does, it adds squared value of coefficient as a penalty. So let us say if we have 2 as a coefficient, so it will have 4 as its penalty. Whereas this lasso regression will only have the coefficient. Let us say if the coefficient is 2, then it will only add 2 as a penalty, whereas ridge regression will add 4 as penalty. Then it can make coefficient 0. This is the most important difference in between ridge and lasso, that it can become, the coefficient can be exactly 0, whereas it will try to reduce the coefficient but it will never become 0. Then this automatically brings this point, that is it performs feature selection built in, whereas it do not perform any feature selection. So if we are using ridge regression and if we still want feature selection to be taken care of, then we want to use some other technique who will only perform feature selection, and then we can use ridge regression. So better is to use lasso regression when we want feature selection. Both of them are used in different scenarios. Useful when there are many irrelevant features. So let us say out of 10, 8 of them are irrelevant. So if we make, or if we omit them, then nothing is going to happen because they are not important for us. So when there are a lot of features that are not important, we can go for lasso regression. Whereas for ridge regression, when there are very highly correlated, or when the dependence of the features, so let us say if features are dependent on each other, So what will happen if we use lasso regression? It will try to omit. So obviously that will affect. So when we have a lot of irrelevant features, we can go for lasso regression. And when there are features that are related to each other, there is correlation in between the features, we should go for ridge regression. Then this is not a very important difference. It produces a sparse model, and the second one, it produces a model with smaller distributed coefficients. Then it is more sensitive to correlated features. So obviously if out of 10 3 or 4 features, they are dependent on each other, and if one of them is gone, then it will automatically affect the other ones also. So when we have correlated features, or when features are dependent on each other, we should avoid using lasso regression. Whereas when we have correlated features, ridge regression works best there. So this was all about ridge and lasso regression. Then we have discussed this L1 regularization and L2 regularization as well. So what I was thinking is, as for machine learning, Python is required. So what I was thinking is, should we start a series, or start uploading one video on Python where we will be doing hands-on, not just the theoretical part. We will be actually coding out the things, and we will be seeing how exactly things work out. So if we should start the series, or we should start uploading one video a week for learning Python, so should we do it? Please let me know in the comment section. And even if nobody lets me know, I am thinking to start it. So yeah, that's all for this video, and thank you. See you in another video. Bye.